So this is going to be a short presentation on how you can make professional looking schematics for your publications or reports or whatever you're doing. So the most common way of making professional looking schematics is by using Schematics, which is a package for LaTeX. It is very extensive. It has probably almost all of the symbols that you can think of in used in electrical engineering. But it is extremely complicated to use. By complicated to use, I mean that you have to actually design the circuit using code, basically. For example, this is just one random page I'm seeing. Just imagine, just to have 3 components, you probably have to remember all of these things. You have to know like the node here, and how do you space things and all of that. So it's really complicated. And if you do a small mistake, probably you get lost in all of this code. Yeah, it's nice. It looks really nice, but actually takes a lot of time to create these types of figures. And instead of probably doing some serious work, you'll be spending like 2 hours, 3 hours just to create one figure. At the end of the day, you feel like, okay, what have I done? Just created a simple figure. So let's say we want to actually have figures that look as professional as this one, but we don't want to go through all of these difficulties. So what I've done is I've actually extracted all of the, not all, but most of the components that I believe that I use personally, and those that I believe that people would actually find useful from Schematics, and created the symbols for them in Inkscape, which is much easier to use than Schematics. And so I'd like to share today with you how you can use these things and make your plots, not plots, make your schematics look even nicer. So first, let's have a look at, so I have a repository where I have uploaded my symbols. So this repository, you can read to know how you can do things, but basically there are 2 files that are important. One file, which is the SVG file, which contains all of the symbols, and the other file, which contains all of the fonts. Because usually when you're writing a report or publication in LaTeX, the font that you're using is usually modern Latin Roman or something like that. And so it makes sense that your figures are going to, your schematics, also the font matches the font of the document. So for this reason, it is recommended that you actually install this font. So let me quickly go to this part. Let's see. Okay. So for the symbols, when you download the symbols from this file, schematics.sim, this one, you actually, if you're on Linux, you put it here. Let me just go back. So usually if you're on Linux, there's a place called config. There's your config directory, which has all of your configurations for all of your applications. And then you look for Inkscape, and then you go to symbols, and then you just copy it here. That's all that's required. Next, for the fonts, you download this. These are, by the way, are free open source fonts, so I'm not doing anything illegal by providing them here. So you can extract this one, and then you go again to home, your username, and then the fonts. And then, as you can see here, I have them here, which can be found here. So with everything installed, then all you have to do is you go to Inkscape, which I have already opened here. Now this is Inkscape. And before actually I show you any of the symbols or whatever, I just want to tell you that the symbols where I had to do some slight modifications so that they actually fit on the grid here, such that it's very easy to move them and it's very easy to connect them with lines and all of that. So the symbols, when I created them with using a 1mm grid. So basically 1mm is something like this, and so, which means that if you want to use the symbol, you have to actually set your own grid to this. So you have to set your own grid to 1mm so that the connection points of the symbols actually fall exactly on the grid lines. To do that, we can go to properties here, document properties, and grids. And as you can see here, I have grid unit in millimeter, and then I set these things to 1mm. So just to show you, like, just focus here maybe a bit. See, if I make this a 5mm, how it looks like. You can see that now it's the grids actually are 5mm apart, or the grid lines or whatever they're called. So now back to 1mm, we have something like this. Another thing I did was when I created the symbols to work exactly with 0.75 point. So which means that the wire, this wire, the thickness of this wire is 0.75 points. This is important because you want actually the wires to connect seamlessly with the rest of the symbols so that you don't have very ugly, like for example, let me just show you quickly what I mean. You know, let's say this is slightly larger. You can make this like, for example, 2. Yeah, it looks ugly. So let's say you haven't used Inkscape. I'm assuming at the moment that you have used Inkscape, but let's say you haven't used Inkscape before. So basically when you open Inkscape, it looks like this, except that you probably wouldn't be seeing all of these parts here. So let me just close this. So what you need to do if you haven't used Inkscape before, it's actually a very simple program, so don't be wary of using it. It's actually quite easy. So do this part first, which comes here, and then you do this part grid. Then you set your 1 millimeter, 1 millimeter. After this, next step you have to do is you come to, I think, object, and then you see fill and stroke, where you define how your wires are supposed to look like. And this one will open for you this sub menu here, and then you go to stroke style, and then you change your stroke style to 0.75, and that's all that you have to do. Now, every time you close Inkscape and you open Inkscape, you probably will have to set all of these things again. So to avoid doing that, you can come to File and Save as Template, and give it whatever name you like, and then you just click Save as Template, and then that's it. And then you can close Inkscape and open Inkscape. These guys will always be the same. I just forgot to mention something. So when I do create a new one like this, if I want my this is like a wire. Let me just show you. I think I probably am not exactly saying what I'm doing. So this is the pen tool, which is like the wire. So the pen tool, I clicked on it and something like that. So notice that when I clicked on it, this is the thickness of it. Let's say I make it 1. So it's in point now. 1. Sorry for that. Yeah. So let's say I would like this setting to persist. So all I have to do is, you see this pen, I click on it twice. Then it opens for me a new window where I can say, select that I can make the default style from the current style. So then I just choose this option, this on tool, and then I say take from selection. After you do that, then this actually will persist. Of course, make sure that you save everything as a template, and then it's fine. So now let's assume that you've already done this part. Of course, this so far I'm just explaining like how you can set things up so that the rest of the thing actually looks quite easy. The next thing now is, obviously, as I said, these symbols like these ones here, which you probably should have placed here. And if you had done that, let's go back to this part. You see this symbol here. This is this symbols page, which is where we see all the symbols that we currently have. If you can't see the symbols, then all you have to do is you come again object and you say symbols, then it will open this part. So as you can see, these are all of the symbols that I have extracted at the moment. I have probably, I have resistors, memristor, capacitors, different types of capacitors, diodes, BJT, MOSFETs, op amps, the sort of things that probably most people would be using. And then I have some digital logic gates and whatever, and then some nice how do you call them, arrows, so that I don't have to really recreate them every time. So now I'd like to show you how easy it is to create a schematic here. So it's really easy, not that hard, not hard at all. So just to walk you through the process of creating a schematic and all of that. So all that I've said so far, basically we just set up the sort of things that you do once and then you're done. Now it's like, let's say you've already installed everything, installed the fonts and all of that, and so now it's time to create our schematic. So for just as an example, I'm going to do one which is let's say a 5 transistor OTA, which everybody is probably familiar with. So to do that, so as you can see, I just basically have to take my symbols and place them on the figure here. So as I said, you don't have to worry about font size, about making sure that the symbols are big or whatever, because they have already been created for a specific page size. So this entire grid that you're seeing here is like an A4 page. So usually, obviously, before you create your figure or whatever, you obviously have an idea at the back of your mind, how big is your schematic going to look like? Is it going to be the sort of schematic that will occupy one whole row on your paper? Or is it going to be something that probably will occupy one column or something like that? So just have that at the back of your mind, because it's really important that one of the things that I don't know if you've, because I'm assuming here that if you want to go through all of this process of creating nice looking schematics, it's because you probably are going to be maybe publishing it and something like that. And it's really important that when you create your schematic, you don't resize them in LaTeX, because if you resize them in LaTeX, they will always not look as good as they should be looking. So just make sure that your figures actually have the right size. I mean, just have at the back of your mind how big your figures is going to be. Is it going to be for a single column, or is it going to be for a full row? And then you create your schematic based on that, so that you avoid having to resize the figure at the end of the day. Now let's assume that we have a single column that we are going to do. So yeah, let's do a single 5 transistor OTA, which is very simple. As you can see here, I have a huge amount of different types of MOSFETs, because not all the time, probably, like if you're doing, for example, if you all you care about is like using MOSFET as switches, then this makes sense. If you use MOSFETs as, let's say, the typical ones that you find in analog circuits, use this one. If you care about maybe showing what the bulk is doing, you'll have this one. Anyway, so let's choose the one that people usually see in analog circuits. So 5 transistor OTA basically means two NMOS down, 2 NMOS at the top in current mirror configuration, and 1 tail current at the bottom, and then that's it. So let's start here, and then let's start putting them. So let me zoom in so that we can see clearly. So as you can see, all of the symbols were created so that they fit this grid very nicely, so that you don't have to worry about any of that. So let's take this guy and then place him at the top of the grid. Now, if you haven't used Inkscape before, I am going to recommend that. So at the moment, all I'm doing is I'm just moving it with the mouse. So usually, because you can move in any direction, sometimes it can be a little hard to snap this guy on the grid exactly. So let's say you want to move your mouse in any crazy way, but you want the motion to only be along the vertical direction. So you can always hold Control. When I hold Control, then you can move up. You can see I can move up easily. Now, if you want to go in the other direction, then you do it like this, something like that. So always hold Control if you want to be like more precise in one direction. Anyway. So I have this guy at the moment, and then for the second guy, probably I'm going to duplicate this. So yeah, you probably need to learn a little bit of the shortcuts in Inkscape, but after that, it's really, really easy. So duplicate, it means Control D. It's duplicated on top of it, so now I can move it like that. So what I can do is I can then flip this guy horizontally, right? This guy has to point in the other direction, so I press H. So as you can see, the font actually has looks very bad now at the moment, because it has been mirrored, but we can fix that later, so we don't care too much really. So let's, I think this is enough, fine. Now for the PMOSes, let's go with the PMOSes. Bring the PMOSes, let's say here maybe. Let's make it slightly okay at this point, okay, fine, no big deal. And then duplicate again, another PMOS, yeah. Now let's take this guy and flip, because I mean, probably should be showing you a one for, but I assume that everybody is familiar with the 5 transistor OTA. So we flip it like that. Let's say this is enough. And then yeah, so this guy can come here, for example. Very good. So as you can see, the structure is already taking shape. And then what do we need? Maybe a VDD. This is the VDD. Put him here. Let's say something like that. And then we need the nodes. These guys can come here. We need also this guy to show that where we are making connection points. Maybe a capacitor at the output to show that it's driving some load. And I think probably that's okay. We need one more. This guy down here, Control duplicate. So something like this. Anyway, I think probably I'm a bit happy with this right now. So as you can imagine, just like that. Now, this is one important part now. Usually, symbols are not meant to be used like the way I'm currently using them. Symbols are meant to be something which are fixed, which means that you are not supposed to be changing the symbol. So, for example, like right now, if I want to change anything about like the M1 to M2, it's not possible. But the way you can do it is you can select all or make Control A, and then you go to Edit, Clone. You say, you see this one, on link clone. So when you say on link clone, it means that the symbols now that appear on this page right now are become editable, which is exactly what we want. So you just remember the shortcut, which is Shift Alt D. So basically I can come here, I say Shift Alt D. Now it's editable now. So now it's editable means I can actually start changing stuff. So let's say this guy, remember I had flipped this guy before with pressing H horizontally. Now I can just double click, I moved inside and I press H, flipped. Then now if I want to edit the symbol here, I press T for text, then I go to. Now as you can imagine, the how do you call it, the font that I'm using is already set to what do you call it, the Latin Modern Roman font, those fonts that we had installed. So that's why the fonts look like this. Now again, let's say this guy, let's come here, double click inside, I moved inside the group, I press H, I flipped it, press T, I come here, then I can name this guy, for example, M3, done. Similarly, I come here, I say M4, what the hell, yeah, it's done. So now I click outside and I'm done with this part. So I've labeled them nicely. Similarly, this guy, we would like him to actually be the full, go probably extend a little bit. So again, I can double click inside to enter the group. I move this guy all the way probably here, maybe something like that seems to be enough. Then I can come here now. Now we would like to actually make this guy longer. So this is like a wire. So to edit a wire, you have to press N. It gives you the nodes of the wire. Maybe you can zoom in, and then all you have to do is you just click on it and then you drag. So since I want to make sure that I don't actually go up or down, I'm going to hold Control and I'm going to drag it. Something like that. I'm happy with it. Then escape. I'm done. So this guy now, I can probably take this guy and move him slightly closer so that it doesn't look to be far apart. Similarly, this guy probably I can bring him down. I can come here. Similar, I've just pressed N, then I move it like that. I'm done. Now for the rest of these guys, we would like to connect them. So we can come here to the pen tool or press B, something like that, B, and then we can move him like something like this. Again, like this, and then let's just take maybe this is enough. Okay, looks nice. And then maybe we can come here and then we can do it like that. Let's put him in the center. You know, I'm actually not really eyeballing things to know that if I'm at the center or not, but let's just, seems fine. So far it's actually starting to look almost like a 5T OTA. Then I can probably do this because I want to put this guy here. Let's say, let's bring him now, put him out here for the moment. So let's be a little bit fancy. Instead of putting my V in here and V in here, let's bring the cable all the way this point here. So let's say I take this guy, I bring him like this way, and something like that. Okay. Similarly, we can come here and then do this, something like this, and then I can take this guy, bring him here, and then duplicate. I have another one. Then I'm going to rotate. So rotate, you can either come here, which is rotate, or you press Control square bracket, the open one, the one you use to open or close, I mean. Something like this. Again, for this guy. Yep, you can do it like that. Like that, it's done. And then for this guy here, we can just press B for the brush or the pen tool. And then it's done like this. Now let's show that where the connections are made. We can take this guy, as you can see. So usually what I like to do, I just press Control C, which is to copy, or Control, so that I can paste wherever I go. I come here. So I would like to put this guy here, exactly here. So how do we do? Again, as I told you, hold Control so that we move him horizontally. So now we see that it has snapped in this vertical direction. Then I move up, Control up, then snapped. I'm done. Similarly, I come here. Let's say Control this. It snapped. Snapped. This guy is done. Now let's come here. Same like this. Okay, seems to have snapped. Has it snapped? Nope, it hasn't. Okay, now it has snapped. Alright. So what else do we need to do? Okay, there's also one other guy here. I press Control V for paste. Do it like that. Alright. Okay, now for this guy, it seems to be a bit too far at the moment. Let's bring him maybe close. Okay, who cares? This part, then Control V for this guy. Okay, then I bring him probably like this. Yep. Yes, I'm in the center, and then okay, this guy probably now is a bit too far. Then we can move him like that. Then we can bring another one like this, and then drop him here. I'm happy. Now we need our grounds. I forgot to place them initially, so bring my grounds, move him like that. Done. The second ground. Bring him down a bit. Done. What do I want? Okay, it's almost done, I believe, and just looks very nice, really, to be honest. And then what do we need now? We need probably to do some labels like V in, V out, all of these things, so I can have my V in. And then I have to unlink it so that I can edit it. Shift Alt D, I have unlinked it, and then I come here, I say, okay, it's already V in, so there's no need to do that. Now, usually, let me just show you. So we can probably eyeball it like that, and we're happy with it in the center. But if you are probably a sort of guy who is very, very, very particular about having things centered properly, what you can do is probably create a line like this. So now I have a line. So I'm going to center this guy with respect to this line. So I click on this guy first, this guy second, then I come to this part here which is called Align and Distribute. You can also find it here, I believe. It's somewhere around, to be honest. I don't know exactly all of these things. I just know the things in terms of the shortcuts. So I can't really remember all the where they locate. Okay, it's here. Shift Control A, you get it. So you go to Align, and then you see this guy here. It tells you the center on horizontal axis. You do it like that, and we almost got it. Similarly, you can bring this guy here, for example. Okay, let's see. Move him so that it's this centered line. Make sure. I mean, this is, of course, you probably don't need to do all of these things, but if you care too much about having things perfectly aligned, this is what you need to do. Again, this guy, I would like to center it here. Then I'll just have to center it vertically, something like that. So now we have a perfectly centered V in. Then I can take my V in here. Probably I come here and then zoom in. Then do him here, and then I can do out. Yeah. So now I would like to center this guy on this line. I already have a line. Okay, what I did just now, I said Control Shift G because probably it was grouped with something else. I can come here and then I center it with horizontally. It was already centered almost. Yeah, I guess this is probably. Oh, I forgot for this guy. Maybe let's just. Yeah, something like this. You move him here and then go back to this. This guy probably will just give him a VB. Don't know what's going on, to be honest. Let's see, Control Alt D to unlink, and then I press T to go into text mode, and then this way do it like that, and then align horizontally. Yeah, so let's see. So I guess I'm almost done, to be honest. It looks already nice. And then if you'd like to add some how do you say, some annotations, maybe, let's say, I don't know, you're trying to make a figure and then to show that probably the feedback is positive, maybe you can have some arrows. Let's say I take this arrow, then you can rotate it like that. Maybe you can start adding, maybe if you'd like to show that the current actually is flowing in some direction, just rotate it like this, maybe. Okay, then you can, I don't know, I probably should have left some space for this guy to show how the current is flowing, but anyway, you get the idea. Or maybe you would like to show that the current is moving in this direction. Yeah, why not? Maybe something like that. And then maybe put some text on top of it like this. Yeah. Then you can Control Alt D again to unlink. Then call this guy I. Give him the name out or something like that. Yeah. Then you can obviously center it if you like. This is more than enough. Give it some colors. All you need to do is, how do you say, you see the color palette here, you can just choose one. I'm happy with that. Then for some reason, let's say you would like to show that maybe looking from this output node, the output impedance, then I already have some fancy, how do you call them, included, arrows included. So I'd like to rotate this guy to the like this, and then I horizontal like that. Then I unlink it, then I come here now. Maybe I'd like to point like this. So here, let's say I'd make him long, just like that. Maybe, who knows? Something like this is nice. Let's say you would like to give it more curvature. You press N again, you click on it, and then you can see this adjustment markers. Then you can come like that. Maybe you should like it like that. Yeah, I guess almost done. To be honest, then there's nothing else to. Maybe sometimes. Okay, let me just show you one extra thing. Let's say you would like to have some Greek letters here because because not all of the Greek letters are easy to type. So I have this text of all of the Greek letters here. So for some reason, let's say you would like to, I don't know, use the Greek letter. Let's say you have this, or let's say you want to use something like phi1. Let's take this. Okay, for now, instead of v1, I would like phi1. So I first of all unlink these guys, and then let copy phi. Where's phi? Yep, phi1. Copy, paste phi1. Then you can probably use it somewhere else. Let's say you're not too happy with this. All you have to do is to maybe slightly move it down, move it closer, maybe if you like, and then that's it. Basically, there's nothing left to do. So with this guy probably done, all you have to do now is maybe save it and then use it in your PDF. I mean, use it in your LaTeX. So right now, all we have to do is maybe just right click, Control G to make it as a group. Then you hold Control Shift R, which means that only select this region, and then you can come to File, Save As. So here is what I usually do. So because I want to have this file editable in the future, if I want to make some changes, or maybe I want to use it as part of another larger figure, I will save it as an SVG file, which means that a file that's really editable, which means that if you have layers and all of this fancy stuff, yes, they are just, you can edit them. So I save it first as an SVG file, and then after I'm done, because LaTeX expects you to use a PDF file. A PDF file means the figure is already rendered. So all the LaTeX compiler, as it's called, will just include that LaTeX file in your document. So after you're done, maybe you can give it a name, whatever. Let's save this guy in home. Okay, let me just say, I don't know, let me just save him somewhere. Where can I save him? Let's save him somewhere, whatever. Say, yeah, let's save him, call him whatever, say 5t ota.pdf. Then I can do save. Now this is important here. You want to actually convert text to path. What does this mean? This means that all of this stuff that we have used here for M3, M4, we actually don't want to, we actually want to have the PD, we want the user who's going to actually be viewing this figure in his PDF viewer not to have these fonts that are used here installed. So for that to happen, it means that convert the text from an actual editable text into just like vector graphics. So basically this is what it's doing here, and that's all you need to do. Just remember these things, and then you press OK. After that, these guys will no longer be editable text in the PDF file. They will be just like a line like this. So now let's go back to my where was I? This is my figure. And then I can come here and do ocular, open it. Then I can see my figure. So this is my complete figure, which you can now include in your PDF file. Yeah. So basically, which in your LaTeX. I'm sorry. So I guess that's all there is to it, to be honest. Of course, it took me a lot of time to explain these things, but you can imagine, like, it doesn't take it doesn't take a long time at all to do this once you have become slightly more proficient in using the tool, and you don't need to remember all of these how do you say, these types of commands. Yes, of course, here you have way more flexibility in terms of like everything is code or whatever, but at the end of the day you have to find some compromise. Yeah, it's nice to always generate things on the fly, but at the same time sometimes it's nice to be more efficient with time. I mean, all of these things, I probably can do all these things in LaTeX, I mean, in Inkscape very easily without the need to have to remember all of these parts. So I guess that was all I wanted to say in this video, and I hope you find it useful. And yeah, that was it.